Well, good morning, good afternoon, good evening, wherever you are in the world. Thank you for tuning in. I hope everyone's doing as well as can be expected given the circumstances, and thank you for making time in your day to join us today. My name is Spencer Paul. I run the North American division of DoiT International, and I'm here with Snyk and Liran, who I'll be passing over to momentarily. Just by way of introductions, so everyone knows who's on this call and kind of where we're going. So the two organizations, one is the one that I represent, DoiT International. We are a multi-cloud engineering team that functions as an augmentation of existing tech teams to evaluate public cloud, meaning Amazon, Google Cloud, and Azure. So we work really closely with engineering teams like some of you may be a part of on this call to make sure that your experience testing and potentially moving to any of these platforms are as smooth as possible. We also are very fortunate to have with us Snyk, who's actually the precipice of this entire conversation. So I'll give a quick introduction, look at the webinar agenda such as it is, and then I'll pass it over to Liran. So Snyk, despite the pronunciation, is actually pronounced just like an EA, but Snyk has been around since about 2015. Used by over 400,000 developers worldwide. Hopefully some of you are on, and then some of you who may be new to the platform are here today. But it's a dev-first security company that really is targeting developers to help find and fix vulnerabilities in open source container images. And if you're on this call, that's probably pretty relevant to you as well. So I think the content of today's conversation will be really fruitful. To that end, we'll be going over a few things. We're going to start off with best practices for Docker image security. We're going to kick it from there to reviewing vulnerability trends in the industry writ large. We'll talk about Docker Hub and two-factor authentication, something that I know some of you are already familiar with. Then we'll dive into some real-world vulnerabilities that impact containers in production. This is only useful if we can actually give you some real context for what this looks like in the wild, so to speak. So we'll head that direction then. And then we'll talk through live hacking your container. But before I get any further down the path, I want to quickly take a moment to introduce Liran Tal. He's a developer advocate over at Snyk. He'll be running the majority of this webinar. And with that, I'll turn it over to Liran. Thank you so much for being here.
Thank you, Spencer. Hey, everyone, and thank you for joining us. And hope you're going to get an interesting session for the next 45 minutes or so. My name is Liran. I'm a developer advocate at Snyk. We build developer-friendly security tooling to help developers fix problems in their open source security issues, on their projects. I'm also actively involved in the Node.js security working group to help improve the state of Node and the NPM ecosystem and JavaScript as a whole. I'm involved in some other projects as well. Had a chance of reading some books as well. So if you're interested in any of that Snyk-related open source Node security, I'll be happy to get a ping from you. So, definitely go ahead and save your questions throughout so we can save some 10 or 15 minutes at the end, as much as we can from this session to answer them. But if we don't get a time for that, you're welcome to ping me or Spencer or anyone else that you got the communication with, and we can go ahead and kick it off now. So we're going to talk about this in this session about securing your containers by breaking in. And obviously, we're going to talk about containers. And so just putting it out there, the adoption of container technology has been, increasing at a remarkable rate. I think probably don't need to convince this by anyone, but just to give you around some numbers to show you like how impactful this is, right? So Docker Inc., the de facto, company behind Docker Hub, has been reporting more than 1 billion container downloads every 2 weeks or so over the last year, about 50 billion to date. That's a billion with a B. With more than 1 million new applications getting added to Docker Hub, as a form of Docker images and then turning into containers just in the last year. So, immense growth. This is, our starting point. And as we are talking about securing your containers, we want to talk about what are the best practices to actually build your container to start off with. So this is all around, not even going through the production state, but even much before that. How do we get a good Docker image that is a good starting point without all of those vulnerabilities that get added? And to that, that extent, I'm going to talk about all of those vulnerabilities, and that's part of what Spencer talked in the agenda. this is, we're going to talk about how those containers get exploited in the wild, through real applications when they have vulnerabilities. So to start off, first thing is, prefer minimal base images. And what exactly does that mean? So oftentimes you actually, you might start projects with a very generic container image. It could be something like, starting off a Dockerfile with importing from Node or from Ubuntu or something like that. And that is kind of like the default. However, when you specify that, that Node image as a default, you should take really good consideration that the fully installed Debian stretch distribution is going to be the underlying image that is going to be used to build it and then run your application. So if your program is actually or your project, whatever you're actually gonna build with a container image, doesn't require all of those system libraries that you get with a Debian stretch with a full image. Maybe it's better to avoid using this full-fledged, full-blown operating system as the base image. And so let's take a look at what does it actually mean, right? What it actually mean to have those vulnerabilities and those libraries in that image. So what we've done, a while ago, about February 2019, so last year in the State of Open Source Security report, and a new one coming up probably very soon for this year. And that is, we took a look at all of those top, most popular Docker images that we see on Docker Hub, and we've plotted all the amount of vulnerabilities that each of them have just by default, just by requiring, from Node or from Postgres or from Nginx. Just by doing that, these are all the vulnerabilities that we're pulling in just by default on those containers. You can see the official Node.js image ships with 580. I've run the numbers actually pretty recently just to have a comparison here, and it was pretty much the same, right? It was a few numbers up and down, but the overall trend across all of those 10 images is pretty much the same. And so if you look at it, kind of in another perspective, it means that any of those Docker images that you'll pull here, they at least have 30 publicly known vulnerabilities in them that you just take in by default. And this trend of increasing security vulnerabilities being reported is something that is well known around system libraries as well. It's not something specific to container images. It's because they are actually based on those Debian or RHEL or Ubuntu kind of OS distributions, and so those actually map into the container images. And you can see the trend as well. It's not decreasing in time. We're actually finding and people report more vulnerabilities over time. And so if you remember that one piece of preferring minimal based image, which we'll get to in a much more depth afterwards, you'll see how impactful that is and how we can get into a container, basically hack a container in just by finding one library that is vulnerable. So we'll get to that a bit later, but for now, kicking off with the next one, and that is least privileged users. And it's something that is, the fact that you're using Docker, right? 2015 or 2020, if you want, kind of like technology, doesn't mean you need to forget all of those, 20, 30, 40 years of very basic and important Linux kind of best practices. And that is, do not do the insecure default of using the root user for your Docker image. And it's a very, very small example of how does Dockerfile looks like and what does it actually map to. And so what's happening here is I have this Dockerfile using an Ubuntu base image, and if I didn't have this specific Dockerfile, what would actually happen is that the root user will be used by default. So what I had to do here to fix the problem, this is the fixed situation, where I'm actually adding a new user, the Liran Tal in this case, giving it a false shell so no one can log in with it, making it kind of like a system user. And what we actually want to do at the end of it is, probably assign whatever permissions needed in, whatever directory content you're passing in, which is in my case /app. And of course, don't forget is the fact that we need to actually tell the Docker container to use this user before we are instantiating our process, which in this case is a Node app. And so that was Ubuntu, and it has some systems come, or Docker images come with predefined other users that exist on the container that allow you to do the same thing. And this is an example with Node Alpine, which gives you the Node user. So I do not need to create it beforehand. I just need to provide it the same permissions, and then make sure that I just use that a Node user before I'm spinning off any other processes. And so if we need to take anything off from this best practice is by default, right, we get a Docker file that is insecure, right? No one is running that in any specific user. So by default, if you did not specify any other user, that's going to be the root user. And we're going to see how in the demo of the live hack, that could be very crucial, because if someone can get into the container being a very privileged user, root, versus being a very non-privileged user, could have a lot of impact in terms of how do you mitigate it, and the security attack surface and all of that, kind of like results of getting the root access. Let's talk about two-factor authentication, and that is something that is not really related, very specifically to Docker, but to the end ecosystem, right? But we want to see what happens on Docker Hub, which is where we pull our images, and I pull my images from there. I'm pretty sure people, on this webinar might be sending off their images there to host them as well. So we put a lot of trust in those images that are, on Docker Hub or maybe somewhere else, and we use them for running our containers in production. So it's actually critical to make sure that the image that we pulled is the same one that was pushed by the publisher, and no one else had maybe compromised their accounts and published a malicious version of the image instead of them. And so that's kind of like how how precious are your container images in that sense, right? Security practices take many different shapes and forms, some of which are very easy wins. For example, choosing the right passwords, a strong password, enabling two-factor authentication. These are some easy wins that we can do even for the container management side, which is in this case Docker Hub. And so to give you like a bit of a context before I go and deep dive into Docker Hub, let's talk about what happens in a different ecosystem. Let's talk about NPM. NPM is the JavaScript registry for projects, powering the browsers and Node.js and other platforms. And so what I actually want to talk about is, what is the state there? Do we have 2FA on NPM? What do you think? And I'll let you like a second to run just the numbers in your head. How many people have actually enabled 2FA? And so the only public number I have, which is, it's a bit like 1 or 2 years outdated still, but it's the only public number that we have from NPM sharing these stats, and that was 7% of maintainers that have enabled 2FA. So despite actually 2FA being available in NPM since the end of 2017, so this is almost 3 years, we still do not have like the majority, like not even the half of the ecosystem enabling it. So that's an interesting relation point that we can like now compare what happens in Docker Hub. And so let's talk about Docker Hub. Let's see what happens there. What do you think? I'm interested to know, how many of you have that 2FA enabled for your user? Try to think, for your team, how many of them have it, and throughout your organizations. And even despite the fact that Docker Hub, spans these like millions of Docker images, billions of downloads, what is the state there? So the state is, as exact to the data of October 1st, 2019 was zero. Zero people were actually having that 2FA enabled. And the fact is that it was just not available in the Docker Hub registry at that point. And so it's an interesting kind of like a drama story that happened in the ecosystem. And it goes on and starts with someone on the Docker Hub repository on GitHub actually chiming in and saying, we are going to roll out this two-factor authentication support coming out end of June, and reminding you this is 2019. And people from open source community saying, thumbs up, amazing, let's do it. Except what happens is, it didn't really happen at the end of June. So a caring user jumped, on the issue in July and reminded all of us, hello, this is July, what's going on? We don't have 2FA yet. And then came August, and then another user jumped in August to remind us that 2FA capabilities are still missing from the largest Docker container images ecosystem in the world, Docker Hub. Guess what happened in September? Still no 2FA. So it took time to implement all of that. And finally, October 2019, just a few months ago, sort of good news, right? It started off with this post about, the same person that actually made that commitment. They probably will not do that again in such an open and public manner, but made that commitment to kind of like roll this out end of June, saying that they will be rolling out public personal access tokens, which is not the same. So people were still happy with at least with this news. And later on, indeed, 2FA got launched. This was like taken. I took this screenshot like 1 or 2 weeks after that personal access token. So it was still October, and then we all have it. The time that when I enabled it, when this was all announced, it was still like a beta feature. But definitely the takeaway from this session now is go ahead and enable 2FA for your organizations, for your users. Make sure that no one can compromise your accounts. In NPM, we had a lot of security incidents where very popular NPM packages were basically just compromised because the the account credentials were very weak. So people were using passwords that were leaked. Previously, it was not a problem to just enumerate and brute force it, and people were using very weak passwords in general. There's a whole very public documented record of all of that. So again, if you're interested in any of that as well, just ping me afterwards or go ahead and ask questions for this session. And so the next thing is, how do we leave out sensitive information out of Docker? Out of the Docker image that we're building, sometimes we may need to provide some tokens, some secrets that are just useful to build the image, right? We need to access some secrets on a private repository somewhere, but how do we do it in a secure way that do not don't like leak and pass the credentials, the secrets files, or whatever we have there into the actual Docker container that is then running in production. And so to give an example, like a practical one, I've got this this node project, and it's a very common, probably like a use case around large organizations where some of the NPM packages you'll build are for the consumption internally within the R&D org or something like that. And so what happens is you publish them as a private package to like NPM or like an NPM proxy like Verdace or something like that. And so you need a token to identify with to get them. They're not just available like by an NPM install for anonymous users. And so what I have here is an example where I have like a very simple node project this is a Dockerfile. So a very simple node project in a Dockerfile. And I have this .npmrc getting a file, getting the text of the NPM token and the configuration with it. So this is definitely a sensitive information that I definitely do not want to have in my running container, because maybe someone can then, if they do something like a path reversal attack or some other way that they can get into files on the running container, they can get to this sensitive information, which I don't want them to see. And so let's talk about how are we actually being able to remediate this problem. There are a few ways to do it. I will not talk about like deleting the file afterwards and stuff like that, because these have a lot of other issues which are not, this is not like a best practice to like delete the file after you're done, because then it's still saved as a cached step, a cached layer within the Docker image, and then it's a problem of the image itself, but not the running container. So like there's a different trade-offs. But the really cool thing and easy thing and proper things to do is to use basically multi-stage builds for Docker. And that means, so this is the same Docker file, it's just one Docker file, it's not two, it's one. But what I have in it is I have the first step now from node 12 as build. And in that situation, what I do have is just building, whatever I need. I can take a very big image as well as a base. We said, prefer minimal base images. So for the build step, I can go ahead and take whatever very big image as much as I want that allows me to build. Maybe I have libraries that I need to build based upon and course compile native modules for NPM that I need libraries for. So I can build whatever I want. But then I have the second step that says, from node 12 slim. So already getting like a very slimmer base image. It has, hopefully less vulnerabilities or vulnerabilities. And what I do is I just copy the artifacts from what I actually built before, right, from the build step. This is a common example for Node. It's even more common for other like languages, like if you want to power up Go-based, Golang-based Docker images, where again you need a lot of a big step for building things, and then you only care about the actual artifact out of that whole build process. And this is like the classic example for doing that. And then it also helps you in the fact where the second image is a new one, right? Node 12 theme. So there's no whatever you use like build like that token to build all of those modules, you don't need to pull that in. It's not even required. So it won't be that they're not in the image and not in the not in the final image and not in the running container. And so bringing us back into finding and fixing and monitoring open source vulnerabilities of the operating system in the running container and in the Docker image as well. And I'm saying this kind of like tracks us back because we said how important it is to use that, preferring a minimal base image if you can go as much as minimal as you can. And so this tracks back to all of those artifacts that we're bringing in the form of libraries. And there's like a even more nuanced case here, which is most vulnerabilities actually originate in the base image that you select. And this is why it is so crucial to actually understand what is that base image. What are we using as a base image for the container that we're going to launch in production? And for that reason, two, vulnerability remediation should actually focus on those base image fixes that you can actually like move from one tag to the other. And so this chart shows this like a very simple like decision making, right? Like if for example, so for example, the node Docker image, the official one is based on build pack deps, which is by itself, could be based on either Debian or Ubuntu based distributions. It just depends which tag you're choosing. And then this is like a conscious decision that if someone is using Debbie and Jesse, for example, they'll be pulling in 700 vulnerabilities, just by default, just making that maybe non-conscious choice to use that. They'll be pulling on all of those by default, where they could, for example, have used Ubuntu Xenial or something else, or maybe Debian C to just pull a little bit less if that was good enough for the Docker image. And so we asked in that state of open source security, a lot of other questions for survey, for people to answer. It wasn't just data oriented like we've seen so far. And so we asked them, when do you scan your Docker images for open source vulnerabilities? And so security testing is like significantly important, but if you kind of sum it up, 50% of the engineers failed to do so. We're seeing that 80% of developers kind of like skip that shifting security to the left by scanning their container images at development. So it leads to discovering vulnerabilities at a later time, which obviously is going to be a bit more costlier because maybe you need like to choose a different base image, a different maybe just a tag, but still like maybe there's like some kind of dependency on OS libraries that if you had known better previously, you would have chosen a better image. And so 50% of those engineers, again, fail to just scan their Docker images. And so what I'm trying to get at is you can, of course, use whatever tool makes sense for you. But if you choose to use Snyk, for example, it's very simple to do, right? You're going to do a Docker pull for your image. Not always require depends. This is showing an example with a CLI. And so if you then just run a Snyk test, provided the Docker image, maybe the Dockerfile as well, so we can help you find out how to fix issues as well. That's all that you actually need to, and you can run this in a CI environment. You can run this locally as well for like the devs to as part of their local build to figure out if they need to use a different image. And so this is all that you need. And what happens is if you then import that or do the whole thing from the Snyk UI, where you could like not scan a local image but connect it to something like a Docker Hub or any of the cloud platforms, Docker registries, container registries. And what happens is we'll tell you all of this information on the UI. We'll tell you 862 vulnerabilities got discovered for that image. If you think about it, at that point, developers who sees this problem, it's still not helpful, right? I have almost 1,000 vulnerabilities. What am I going to do about them? How should I remediate them? I need a little bit of help. And that's where the next phase come in. This is the full picture of what happens, right? And so Snyk helps you to understand and which image tag you should actually move to. So it tells you what is the current image that you've actually tested, which in my case was node 10.4. It's an LTS supported image of Node.js. But then it also tells me I can actually do a minor upgrade. I can move from a 10.4 to a 10.16 and already remediate maybe 200 of the vulnerabilities I have. That's really important, right? If I have 200 less vulnerabilities, that's great. And I can also move to different other base images or base tags based on, if I can move, right? Sometimes you just can't make that large move to like an alternative base image because you have some actual dependencies in the OS. Like that's the reason that you choose like a full-blown image, for example. But most of the cases, if there's like no dependency on an OS, kind of like a library, like an operating system library, you could just move to maybe slimmer images. And why not have 54 vulnerabilities instead of 862? it's much easier to then take maybe those 54 and triage them and understand, what is a real impact, what is not, what can be remediated further on, than your starting point, starting off with 862. And this is where the developer first kind of mindset is more helpful. So another interesting input that we understood from doing that research around Docker and the whole state of open source security that spans application language and so many other topics as well, was that 44% of Docker image vulnerabilities can actually be fixed with newer-based images, just like I showed you. And that's a very high percent. That means that 50% based on almost 50%, right? Almost half of all the base images that or the images that we actually scanned at Snyk for our users showed us, that we can fix it. That's an amazing way to help developers or other ops just fix their problems, just by swapping their base images. And other kind of stats around this, right? Number of vulnerabilities by the node image tag. So if you choose node 10, that is actually mapped. It's an alias to node 10 14.2 Jesse at that time when we tested it. And just by using that, if you remember what I showed you before about the build packs, just using Jesse was a very high kind of like a scale of introducing vulnerabilities. So if you are aware of this data, if you're aware of this problem space, you're aware of what to do here, you can make a more conscious decision and go for like Node 10 Slim, or maybe Alpine works for you, can go for that one as well. And so these are like real examples of what happens. But there's even like another kind of insight that we gained from all of this research that we've done, and that is 20% of those Docker images can be fixed. All the vulnerabilities can be fixed just simply by rebuilding the Docker image, and that is because sometimes those Docker images actually have like an upgrade step or an install step inside them. So imagine the Docker image or the Docker file to build the Docker image has this step to like apt get install XYZ. So obviously, if you're going to rebuild it and then like a new install will push in, will bring in, right? Will pull in a new version of that XYZ package that it now has the fix, then that helps you. And so just by rebuilding the images, 20% of those vulnerabilities can be fixed. And so another kind of like insight and a tip for you to consider. How do you find out about new vulnerabilities in your deployed containers, right? In your deployed containers in production. So perhaps an even more significant warning sign that we should look at here is that about 50% of developers will never find out about new vulnerabilities in their containers, right? 45 to be exact. Almost half of them will never find out because they're not monitoring them. And that's the idea, right? With application language vulnerabilities like CVEs that affect both containers or application languages, what we want to do is be able to monitor them. So when there's a new CVE assigned for something that we use, we want to know about it so we can remediate the problem. And again, this is something that is very simple to do with Snyk. Either you connect it to something like your Docker Hub or whatever, or wherever else you store your Docker images, and you can just monitor that directly. Or if you want to do that locally or like test it out or through your CI, it's as easy as Snyk monitor -- Docker node 10. That's the image tag that I have pulled in. That's what I have, and then Snyk will then monitor that on a daily basis, and will let you know if there are issues that needs remediation and give you those advices of which base image tag you maybe want to move to. So we talked a lot about all of those dependencies in our containers, right? All of those OS libraries, and what can possibly go wrong, right? At this point, I assume a lot of you are asking, what can go wrong with all of those container image vulnerabilities? I'm talking about 600 of them, or maybe 30 of them. But what can go wrong? What can actually happen? Because a lot of them are maybe for tools like Bash or some libraries that you may not even be using, right? Or app may not be using. So what can really happen? So for this example, I wanted to show you like a live example of what can actually happen. And I was looking for a story that I can actually give you like the real example, right? Not make something up, but here's a real example of what was going on. So this is taken from 2017 Google I/O event, where they actually showed how you build apps upon Firebase, which is their internal platform. And so what we're seeing here, and maybe some of you have already caught like the small nuance in the code here that is a bit of a red flag that we should look at. And this is like on a real life demo, like throughout the event, right? They actually built something like that. And so what happens is this is a Node.js app, and what it does is upon some event that happens, what happens here is that there's like an image being received, getting downloaded, and then there's like we're spawning an OS process, we're spawning a system process called convert, which is based on if you install the ImageMagick tooling, that's library and a CLI tool, then you can run some commands. So you probably have that maybe on your Mac OS or Linux if you if you use those. And you can go off to your CLI afterwards and do convert and give it an image, resize images, and see how it works. But most of those like full-blown Ubuntu distributions and Debian might have that, right? They might have that by default. And so this is like a problem. And you can see here that it's kind of not even an insecure API, right? For this reason, it's actually a secure API call because there's no other arguments being passed. It's just convert, and there's no like shell interpretation going on here, etc. But just by the fact that using the convert app, that's the problem, right? So I'm kind of like zooming in for this on this for you, so you can understand again more in context what am I talking about. So just by using the convert app to convert images to resize them, that's an issue. But why is this an issue, right? Why does ImageMagick have vulnerabilities, and how would I even know that as a developer? Because I want to use this, I can't do other kind of image processing on the main node app because of the event loop and stuff like that. And there are other solutions to handle this, but this is one of them. This is like an okay workaround to do those kind of things that are off the main thread for the event loop. Except what happens is, indeed, ImageMagick has vulnerabilities. Indeed, it has actually tens of vulnerabilities, and they span through different distributions, as you see here, because a lot of distributions just bundle this. It's a very popular one. It exists for like years and decades. And so this one in particular, doesn't look even that intimidating, right? Improper input validation doesn't sound that scary, but it is. What you can do with it is basically create a issue remote command execution and other things that could be very very critical. What happens is like the bit of a drama around this story is, indeed, what when the CVE went out, it didn't get a lot of attention. And what the people behind this, in terms of the security research, actually put up a whole website to explain it, have called it Image Tragic instead of ImageMagick, to kind of like draw attention to it and give it a name and so on. We remember this from the days of like things like Heartbleed and stuff like that. And this kind of like a trend these days to capture attention and so on. But let's see what can really happen, right? What can possibly go wrong with vulnerabilities in my container? So at this point, I'm going to skip into or slide into a bit of code here. So I'll increase the size as much as I can of my code. I think that's pretty big, and then the CLI here. So let's start off. Let's start off with first run a container image. Let's see that it spins off. Now, while I think it's already like listening and we have the address, and we'll visit that in a second, let me show you what is going on. This is basically a very simple node app. It uses Specify as a web framework. It has the same where is it? Child process has the same thing in terms of what we've seen in the demo. It basically uses convert to resize some apps and then redirects you somewhere. So let's see how that gets used. Can also like just go there manually. So this is the app, very simple. I can go and upload an image. And so I want to show you what happens when you upload a bad image. What's actually a bad image? Let me show you this. So I have an exploits directory where I have an image. I will increase the size of that one so you can see it a bit better. So what this image is, it's a JPEG file. It's a really good example of, JPEG files can have different kind of contents. They're not just like binary data in them. And so it actually uses a feature of ImageMagick that allows it to delegate the building of the image, like the contents of what that image should represent, like on some commands that you give it. And so what I have is I have this view box, which is the layout, and then I fill the data based on, capture whatever is in this kind of URL, and then what you can see is this is the actual exploit, right? There is no sanitization. This is the improper input, and so what happens is I'm able to create a file called RCE1 on the container to actually show you to actually like do something on the running container from the app itself, from an image, which is a user-controlled input. And people upload images to apps today, right? It's not like it's not a restricted thing. So to show you how that works, I actually want to connect into the running container. Let's see how we do that. And I want to show you that there's nothing there. So this is the contents. See, there's no RCE1 file here, which is, I usually put it with the code on the root here. So let's upload it and see what happens. Hopefully that's the one from the with the exploit payload. And it looks like everything was success, and I did upload it. But let's see what happens really on the container itself. I now have an RCE1 file, right? It's empty. I'll bring it a bit up if anyone is watching it from a distance, so you can see it a bit further. But then you can see it has no content, right? They just did detach RCE1, and this actually created a file. And this only happens, there's nothing bad in the code in terms of, it's not a coded problem here. It's the fact that convert as a utility that a developer chose to use, that is bundled with an Ubuntu or Debian, several kind of distributions and image tags, is just there, and it's just vulnerable. But if I don't know that it's vulnerable, if I don't remediate it, if I don't take those vulnerabilities off the container, this is what can happen. So this is why this is actually an important thing to go ahead and remediate those vulnerabilities and bring the prefer those small base images, right? Prefer something that does not if you don't need convert, for example, for this app, if I don't need it, I need to use like a very small image as much as I can. If I do need it, I probably want to track all of those dependencies, right? Those libraries that I have built with my app, and make sure that there's no known CVEs there. If there are, maybe I'll go ahead and now start the triage and go ahead and try to minimize them, or like go ahead and see what I can do to fix them. And so this is what happens, and this is how you can actually hack your container. So let's go back to the slide and talk about some other kind of best practices, and we'll see another kind of like life hack of things that are happening. And so our next one is basically using a linter. Linter is like a known kind of practice. It's just basically static code analysis that a lot of people on the JavaScript ecosystem use. And the idea is we want to use some kind of like static code analysis, like an automation way to scan something like a Docker file, where we can see what mistakes we have been making maybe, and then avoid them, right? To establish the best practices. And the linter usually already has that mapping, that dictionary of says, do not have a Docker image without the root user being specified, right? Maybe please explicitly specify a different unprivileged users. And all of these things, they are best practice here, but those linters are tools that can help us automate this. So I'll show you an example of how I used one of those. Hadolint is an example of that. There are different others as well, but it's a good example. I like using it. It's an open source one, and you can see that when I fire it off over a Docker file, for example, it tells me a lot of things. It tells me some interesting things like maintainer is a deprecated label, by itself, a directive if you want on a Docker image. It tells you do not use upgrade or disupgrade, again, because that can probably potentially get you into a bad state of the Docker image. Delete the apt-get list after installing something, again, to like minimize the base image size, like the image size that you're building, and so on. And there are some other things that it can also tell you. For example, avoid additional packages, right? You do not want to install more packages than you actually need. You do not want to use add instead of copy, because copy and add have different semantics. They are mostly the same, but for tarables that could be automatically expanded to the image that you're building, they have that kind of like functionality which you might want to be aware of instead of just using it. So these are just examples of what it can tell you. And like, why not have that, for example, as a build process, right? Why not have those kind of examples? I mean, well, not examples, but actually output from Hadolint or other tools that you could use for linting your files, or your Docker files to be exact, to let you know that maybe you need to follow some best practices. And so this is another tool that I have on my best practices list for Docker images. And then going back into the application state, right? we're talking about the Docker image and its dependencies, but at the end of the day, we are actually bundling our application as well, right? That's part of the container. That's part of the attack surface. That's part of the payload. That is actually the first, definitely, on the forefront than the running container libraries, because you still need some kind of way to get into and affect those, like we've seen with the convert example. But application dependencies are by themselves also pose a threat, also pose an attack surface that someone can, if they know that you're running some kind of like publicly known vulnerable libraries, they can go ahead and try to send off a few payloads there. And so this is kind of like a mental exercise that I'm always doing, right? Imagine you build an app, Java, Node, Go, whatever your favorite language is. Your mental image of the application that you're building is this following blob, right? This big circle thing, which for you just kind of represents what you're building, all of the apps you're pushing that to production or anywhere else. But the reality, however, is that the code that we actually write as developers is significantly small, and there's like a lot of other research papers showing that like the amount of sizes, the variation is somewhere around like 80 to 90% are actually dependencies and open source packages that we use, whereas probably the code that we write to build something is somewhere along the 10%. And that's even a generous kind of like a metric out of those researchers. There are like more example where like it's like 2% or 3%. And so we rely a lot on open source, and that's great, right? That's amazing. We have a community-powered tools to help us build things, and we do not want to go ahead and like reinvent the wheel, right? We do not want to build the new Spring if we don't need to, right? If that's not the goal of what we're doing for the company. And so this is the reality, right? Understanding this is for me a good way to kind of like engage developers about the awareness of security. And so the trends that we've seen before around open source libraries having in container images having an upwards trend where we understand more and more each year how many more CVEs have been assigned. It's the same for application level libraries, and this shows you that in fact actually it shows you a few ecosystems, and in fact we're seeing something like 88% of growth around application vulnerabilities in the last 2 years combined. So that's pretty big, that's pretty high, and there's a lot of research going on, and so that's why it's also like very important. So application level application language kind of ecosystems have this a bit of a difference between OS libraries, which is there are direct dependencies that applications have, and then there's like indirect dependencies, and the whole tree of how those or maybe a graph of how those dependencies lay out. It's actually something that is very complicated, right? And what exactly is going on there? Where do we find most of the vulnerabilities? So it is very hard to imagine, today that you're being able to build anything without open source dependencies, or like they're like part of it. But then we actually found that 78% of all the security vulnerabilities that we find are coming in through indirect dependencies. You can see it actually varies between ecosystems, but if you take NPM, for example, it's the majority, right? Most of the vulnerability that Snyk finds in reports to its users is going to be around those indirect dependencies. So it's not going to be the express or the specify, like those very classic top level direct dependencies. It's going to be in those indirect dependencies on the tree, maybe 4, 5, 6 level downs that maintainer and maintainer and maintainer actually required as a chain. And so that means that we need to also like understand those dependency trees, and also understand how to fix them and remediate those issues. And this is why this is also like very important. But again, what can possibly go wrong, right? What can possibly go wrong with vulnerabilities in my app? So let me show you another example of what can happen. For that, I do want to try a different Docker image. So let's stop this one. Let's see if the other one spins up. If you can have that ready here. So this is a goof up. It's on the Snyk GitHub repo. You can go to just Snyk goof if you want to replicate this. For example, it's a vulnerable app, by purpose to show you and teach you how it's done. If I haven't mentioned that before, also, like, by the way, Snyk is free, so it's like free for open source, even for private packages. You can just go ahead and try it out. So I'm gonna go and try to. No, I just need Docker Compose up here, and do hope I have Mongo installed. Yeah, okay. Hopefully we're good here. And it's listening on port 3001. Let's try this demo. All right. So I have a to-do up. Hi everyone. And I can give you and can add a lot of input here. You can say I can upload a file. I can do a lot of things here. It's just a demo to-do application. And so what it has is an about page, which is interesting of what happens here, right? This is about page and it has some vulnerabilities in it, but what kind of vulnerabilities does it have inside? So maybe, one thing that can give us a hint is it has this /public URL. So maybe I can go ahead and access the public URL and maybe I can find some other things there. So maybe I can go ahead and do, let's go to this session and do something like, yeah, let's try that. I'm getting the same thing, but maybe is there like a private? I don't know. Let's see what's going on. There isn't, but maybe I can do something else. Maybe I can pat reverse. I can do something like that. It doesn't really work. You can see I'm getting the same, the exact same contents as rendered on the HTML, like uploading a file or a link to the about page and so on. That didn't really work. But what actually happens is this code, the Goof app is using a lot of different open source packages, NPM packages. One of them is called ST. And so if you go to ST, that's a way to run serve static files like we did here, like the about.html thing. It's fairly popular, has around 10K downloads a week, so it's fairly used. Published 6 months ago, fairly active. So this is what I'm using. Except if you don't know exactly what you're using and what vulnerabilities you have in it, then maybe you're vulnerable to some of those issues that can come up and bite you. And so if I went into Snyk vuln pages and I wanted to be a bit conscious, and someone told me maybe try ST, use it, and maybe it's an amazing package, but I want to know if there are like any vulnerabilities in it before I use it, or like which version should I use. And so you can see there are like different packages here, and what I'm interested of is specifically ST. In the NPM ecosystem, like some metadata that's interesting. But what's more interesting is I see that there's like directory traversal in one of the versions, and accidentally this is the exact version that I use as well here. And so what that means is if I were to try, well, first of all, you can go in because the Snyk database is pretty rich, and that's like I like that we're doing that. It's pretty rich on telling you how you can exploit it, what exactly happens, why is it happening, what's the we provide a patch, what are the references. Sometimes a lot of times we just put GitHub references if we have those as well. So like it's pretty you have the full context. It's pretty informational, and so you can see that it's actually not filtering all of those URL encoded strings. And so if you try and do something like %2e, that could be a problem if someone tries this off. And what I mean by a problem is someone can basically access your system, your file system. And so if I went on and tried, you can see my bash shell remembers that I do a %2e, now I'm on my file system, right? This is my my file system on the running container, not on my Mac. And so this is what I can get. So for example, you can see how this is can be very destructive. If, for example, you have left off something like a config.json or whatever, where you had secrets that you stored, even if they were encrypted or whatever, right? If you store those like API keys or whatever that are very sensitive information on the container, because that's how you're building the image, someone using a patch reversal can go into that image, the data, the running container, and get that file. So I'll go back to the slides and let us basically finish off with this demo. I'll be finishing off, and if you wanted to, I'll do a recap in a sec. But if you wanted to send out any questions, this is the time to do so. So we talked about scanning Docker images during development, right? Do those scan as easy as you can, as fast as you can, as early as you can, right? As you don't want to find out about these problems in production. Definitely monitor those application level dependencies that you're using, as well as the Docker images as well. You don't want to find out about that too late again. Using multi-stage Docker builds helps you a lot, in general, to have smaller images, but also in the case for us to remove those sensitive files from the image, it's a useful trick. enabling 2FA, is kind of like a basic security hygiene. You should probably do that for, npm or GitHub and Docker Hub, whatever you're using as an ecosystem. Probably want to have a better, more secure account. And of course, don't choose the root user. That's it's like a default thing. It seems obvious, but you'd be amazed how many Docker files we're seeing. People just use images with the root user. And I will now connect that back to what we said before and the hack, where I showed you that it is possible for the running container, as we showed you, to do a touch RCE1, where we actually we spawned the system process and created a file. But if we had used maybe like a more privileged, like a less privileged user, right? Another root user, we would have been able to run that command, but we would have been contained to the specific permissions of that very unprivileged user. So this is why it's a best practice as well. So all of these best practices and more we have on the Snyk blog. We have a cheat sheet that kind of summarizes all of those. Again, if you need anything, go ahead and ping me or any one of the contacts that you received to get on this session. So that's for me. Containers are cool. Be a responsible, cool kid. I had a lot of fun. So I'm going to turn it off to Noah or Spencer now to kind of moderate the questions, and I hope we have some interesting questions there.
Hi, Liran. Yeah, hi, everyone. So yeah, actually, we had a couple of questions. We don't have a lot of time, so we want to be able to answer everyone, but let's start with the first one here from Yoni. What can you do to prevent post-install scripts from stealing the token?
From stealing the token in post-install scripts. So this refers to npm as an ecosystem, which when you install an npm package, basically you can go ahead and the package author, the one that created the npm package, he is allowed to execute post-install script, like post commands to do whatever they want with it. And usually, usually it's by default, right? By default, npm config and setup are enabling all of those packages to run all of those arbitrary commands, which is a security problem. And so one of the things that you can remediate, allowing people to just run npm install scripts from stealing the token, is first of all, when you install packages, there's both a config and a command line argument where it says -- ignore scripts, and when you install packages like that, they only get downloaded and fetched into the node modules or pnpm, whatever you use, but they are not allowed to execute commands. So and then for the cases where you do need to go ahead and for example, cross compilation of native libraries or something like that, you probably want to just vet that this package is legit. For that one, you can allow it or build different customized step for that. But I guess most of the problem with npm incidents of people just executing arbitrary commands to steal your tokens and other sensitive data and just running whatever they want is usually the problem of indirect dependencies, where it's something that slipped into the chain through compromising an account, and then they actually steal your data. So that's one way. There's probably a different, much different ways to do it through an npm install kind of process and related to the Docker image itself. But that's -- ignore scripts is probably a good default.
Okay, thanks. So another one here from David. So who do you see own container security? Is it security teams, DevOps, developers? And what do you see is the ideal split between them?
Right. So who owns security, container security? I think it's much more of a developer world than it has been, than it was probably 10 or 15 years ago. And so we see that, through the DevOps movement, obviously, and other things. But developers own, as much as Docker as they can in terms of streamlining and owning that that kind of responsibility. And what I mean is, they will probably, to an extent, they will not set up a whole infra or manage the actual orchestration to an extent, but they will do as much as they can in their purview. And that means for me, I was a developer previously joining to Snyk, and what I was doing as well with my team is we own the Dockerfile, right? So if we made a bad anything bad on Dockerfile, like using from node by default and not anything else, or we used all of those bad practices that we've learned how to not do today and use the actual best practices. All of those things, it's devs own them, right? Because devs wanna run fast. Sometimes they want to add a new package to the container. Sometimes they want to move to a different image because they now need a feature from node 12 and it doesn't exist in node 10. And so developers own the container security to that extent. That's for sure. So that's my stand on it, and I'm pretty sure like security is like a shared ownership around organizations. That's kind of like the mindset we want to have. But developers to fix those problems is probably going to be like the easiest way to empower engineers to actually fix security issues.
Thanks.
Do we have any?
I think we have one. Let's take the last question now and then wrap up. So last question. What is the recommendation to scan application vulnerabilities, and can you do it as part of the image scan, or would you recommend do it in before that?
Right. So first of all, like you can, there are some solutions. Snyk, for example, can scan application dependencies along with what's bundled on the container image itself. So you get both of both worlds. But definitely do both as early as you can. And when it's like the simple fact that some maybe not people on these calls, and this is like a Docker related session, but some people don't use Docker, right? They use other means, or there's like serverless kind of like situations and solutions, and so it's not going to be all related around the Docker ecosystem. And so these are kind of like decoupled concerns. They are related. If you can do them together and that fits, that's fine. But you should definitely like probably prioritize as much as you can the code and the dependencies that you write from the application level, since that's going to be kind of like that first attack surface that people outside interact with. And so that relies both on your code and everyone else's code, basically, which is what open source.
Thanks, Liran. I think we have to wrap up now.
Cool.
So you can.
Right, everyone. So yep. So thank you for joining us. We'll be sending off the slides and any content you need. If there are still more questions, just reach out. I'm happy to engage. And Spencer, me, everyone on the call are happy to get any of your questions. So definitely go ahead and contact us. Thank you for the time. It's been a pleasure, and have a good day, morning, noon, whatever it is on your time zone. Bye.